Hi guys, how's it going? This is Siri, and today we're going to be doing our first video in quantum mechanics, and it's just going to be an introduction today. We're going to go through what people discovered throughout their exploration of quantum mechanics and things like that today. Okay, so if we've studied physics before, we've sort of came across, classical mechanics ideas, Newton's laws and everything, and we sort of learned and looked at the world in that perspective, from the classical perspective. And then, the 1900s came along, and then we started seeing some strange things that couldn't really be modeled by what, these earlier scientists have done, especially when looking at the microscopic world. So quantum mechanics, usually has to do, basically has to do with the microscopic world. Okay, and this is the world of atoms, photons, and other elementary particles, which we will discuss in detail later on. So we have atoms, we have electrons, we have other elementary particles. Okay, we'll talk about things like fermions and bosons and things like that later. Okay, so when we try to apply classical ideas to these really, really small things in this microscopic world, things start to break down, and we start to get wrong results, right? So we've sort of had to come up with a new theory that would explain these different phenomena that we've been seeing. And we have different questions that we ask, are electrons identical, and does that really matter? And what does it mean for two particles to be entangled? Those are the sorts of questions. So we're going to be talking about entanglement, concepts let's talk about superposition. We'll talk about superposition. We'll talk about entanglement. Okay, right, so the main thing, that sort of governs this whole study, you might have heard of something called wave-particle duality. And so, can things like electrons behave like waves and particles at the same time? And what does that even mean to, be a wave and a particle at the same time? First of all, what does it mean to be a wave, and what does it mean to be a particle? We'll look at Heisenberg's uncertainty principle. And what we'll start to see is that this world, their probability comes into play a lot, right? We don't have a definite answer. It's never certain. It's never, the path from A to B is never, guaranteed. So Heisenberg's uncertainty principle, we'll cover that. We'll look at, we'll definitely look at, probability, and we might get into, path integrals, Feynman's path integrals. And so that sort of suggests that, if you have a path from A to B, you have if you have a path here, what we say is no, that's not the only path. In fact, you can take all, if this is our domain, if this is what we're looking at, if this is the space and the universe that we're looking at, all of the paths from A to B are actually all taken. And so measuring things actually sort of somehow seems to sort of change what we see versus what's actually going on. So we have some strange things that we can discuss there. You know, so the path from A to B, like path from A to B, as in like if an electron or if a particle like that takes a path from A to B. Right, like say that's an electron. Okay, so we'll take a look at that. And we will look at spin. We'll look at particle spin. You know, what does it mean to be +1 spin or -1, or like, you know, even half, 1/2, -1/2. You know, what does that mean? And so it's sort of has to do with angular momentum. We'll get into that later. This video is just supposed to be like an overview of what we might, you know, cover along this journey. You know, entanglement actually would come next, and you know, there's definitely other things that I'm probably missing, but you know, we could get into quantum information theory as well. Information theory as well, and you know, talk about like some quantum computing. Quantum computing, we'll talk about like qubits. You know, you might have heard of bits, you know, zeros and ones, but like, you know, we can use this idea of like superposition that we've talked about here and say that like, oh, we can have something that's both 0 and 1, but how is that possible? Well, we have to deal with probabilities again, and we'll talk about gates and you know, all sorts of good stuff. Okay, so that's sort of what's in store for us. I think that's it for this video. You know, we'll talk about, I think next we'll probably talk about like what is a wave, what is a particle, what are those experiments that sort of led up to the discovery of quantum mechanics. Why did we need to discover quantum mechanics? What experiments told us that, hey, something's like up, something's fishy with, you know, whatever classical mechanics ideas that we're applying to such a microscopic world. Okay. Alright, I think that's it for this video. I hope you learned something, or I hope you got a sense of what we would be covering, and I'll see you guys next time. Bye!